Today, we are going to talk about adding and subtracting rational expressions that have a common denominator. So again, this phrase here, rational expressions, what that means is that means polynomial fractions. So on Tuesday, we talked about multiplying and dividing these. Today, we're talking about adding and subtracting these, except we're keeping the caveat that all of the examples in this lesson will already have a common denominator, which is good. That makes the problem significantly easier to do. Okay? So here on your screen, you'll see a, let's say, 5th grade-ish level math problem, 5 halves plus 9 halves. And when we add two fractions together, remember that essentially what we're doing is we are adding the numerators together and keeping the denominator the same. So we do 5 plus 9 over 2. Well, that would be 14 divided by 2, which reduces to 7 over 1, or 7, because both the top and bottom of that expression are divisible by 2. So we are required to divide by 2, and we never have to write a fraction over 1 as an actual fraction. So what we're doing today is we're adding together rational expressions, not just basic fractions. So down here at the bottom, you'll see one of those problems. And what we're going to do is exactly what we did up above with the regular fractions. We are just going to combine those. Those already have a common denominator, so all we have to do is add those numerators together. 8c plus 5c. Those are common factors, so we add like terms, and we get, what is that, 13c over 6. That does not reduce, so that is our final answer to that problem. I wish I could say it got harder. It doesn't really. Occasionally, we have to be able to recognize and reduce fractions, but for the most part, that is adding and subtracting these polynomial fractions if they have a common denominator. That's pretty much it. They don't get much harder. Okay, so we're going to do a number more examples of addition, and then we'll go through subtraction real quickly. Again, today's lesson is going to be pretty short, and you'll have a relatively easy assignment this evening that will be due tomorrow. So here's another couple examples. We're going to go through these. Again, you'll notice we already have a common denominator of n plus 3. Our directions don't say add, they say simplify, but what that means is that means add. So we are simply going to add those numerators together and keep the denominator, the common denominator. So 5n plus 15 over n plus 3. Now I need to be a little bit careful here because we can actually factor 5n plus 15 because those two terms have a GCF of 5. So we need to factor that 5 out of there, which would leave n plus 3. And we need to be able to recognize that because since that we have that n plus 3 on both the bottom and the top now, those would cancel. And we would be left with 5 over 1, or just 5. So once we have added the fractions together, we always need to check to make sure that the numerator and the denominator don't have any common factors. Because if they do have any common factors, we are expected to reduce. Okay? We are expected to cancel those common factors and write what's left over afterwards. Okay? Same thing on this problem down below. We already have a common denominator, so we're going to combine the numerators, 3y plus y squared over 3 plus y. Those are not like terms, so they cannot be added. However, there is a GCF in the top of y. So we have to factor that y out. So we take that y out of there, we're left with 3 plus y. And on the bottom, we already have 3 plus y. So just like the previous example, the 3 plus y's would cancel, leave us with y over 1, which is just y. So that in a nutshell is how we add when the denominators are the same. Now, Tuesday next week, we'll discuss how to add and subtract when the denominators are not the same. and that is significantly more difficult. So I'm hoping that this will be a relatively easy lesson, that we can all get a nice, high, solid grade in the grade book for distance learning, and that'll provide us with a little bit of a cushion for what will probably be a harder situation next week. Any questions about addition before we move on to subtraction? Just post them in chat if you have them, and I can come back and cover that stuff. Anytime you have a question, just drop it in chat to me. If I think it's something that would fit well in the notes, I'll answer it right away. If not, we'll hold off and I'll answer them at the end. Okay? So nobody's jumping at their opportunity to ask questions, which means we're ready to talk about subtraction. Well, when we subtract two fractions, we pretty much do exactly the same thing that we just did with addition. And the reason for that is subtraction is really just addition of a negative number. So what we do is we subtract the numerators, 17 minus 3, and we leave it over our common denominator. So 17 minus 3 over 4, well, that would be 14 over 4, which would reduce to a final answer of 7/2, because both the top and the bottom of that expression are divisible by 2. So that's what we're going to do even with polynomial fractions. We just are going to subtract the numerators. As long as they have a common denominator, that's all we have to do is subtract. Now, the tricky part with subtraction is that that negative sign has to be applied to both the 4m and the 2, which essentially means we have to distribute a -1 to both of those terms. So when we do that, we'll have 3m minus 5 minus 4m minus 2 over m plus 4. And then we will combine our like terms. Well, we've got like terms here, 3m and -4m, which gives us -1m. And we have like terms of -5 and -2, which would give us -7 over m plus 4. We cannot, there are no common factors between those two binomials, so that would be our final answer. -1m minus 7 over m plus 4. So again, we have to be careful with these negative signs. We have to remember that this negative sign in the middle applies to both of the terms in the second binomial. Okay, so to make sure that it is being distributed to both terms in the numerator of the second fraction. Let's do a couple more examples of subtraction, and then we will move on for the day. We should be done pretty early today. You might even have enough time to do your homework before 2 o'clock. So here are a couple more subtraction problems. I want to make sure we see enough examples of this so we know exactly what we're doing. So again, what we're doing is we are combining the numerators by subtracting the second numerator from the first, and we're putting that over the common denominator of h plus 1. Again, that negative has to be applied to both of these terms, the 5 and the h. So it's like we're distributing a -1 through the parentheses. So we have 2h plus 4 minus 5 minus h over h plus 1. We combine like terms, so we have 2h minus h, which is 1h, and 4 minus 5, which is -1, over h plus 1. Those binomials are not exactly the same, so that cannot be reduced, and that is our final answer. Please don't be the person that thinks, oh, well, I can cancel the 1s, or oh, I can cancel the h's. Remember that the numerator and the denominator of this fraction are technically protected by parentheses. Those are parentheses we don't normally draw, sort of like the 2 on a square root. The index, we don't draw that. Or the 1 in front of the h, we don't have to draw that. So those parentheses are there. They're just not shown. Okay. Same idea here on the last problem, the last example. We are going to take that first numerator and subtract the second numerator from it over our common denominator. That means that we have to take that negative and it has to be applied to both of these terms, the 2h and the -6. So what we really have there is 17h plus 4 minus 2h plus 6 over 15h minus 5. And then we're going to go in and combine our like terms. So we have 17h minus 2h, which is 15h. And we have 4 plus 6, which is 10. And that is over 15h minus 5. Now this one, though, we are not done. The reason we're not done is that both the top and the bottom have a common denominator. They both have, or sorry, not a common denominator. They both have a common factor of 5. 15h plus 10, if I factor out a 5, is 3h plus 2. On the bottom, if I factor out the GCF of 5, then I have 3h minus 1. So those 5s would be considered a common factor top to bottom. They would cancel. And my final answer would be 3h plus 2. And I'll try to get that a little bit cleaner. Over 3h minus 1. Those are not the same binomial, so they do not have any common factors, and that would be our final answer. Okay, so we've been through examples, and I think, yep, that's the end of the notes. Okay, we've been through some examples here of addition and subtraction. Again, what it boils down to is if we already have a common denominator, we're just going to combine the numerators, which means add like terms on the top of the fractions. Be careful with negatives, be careful with subtraction. Remember that that subtraction sign has to be applied to both terms in the numerator of the second fraction. I looked at IXL again today. I'm still not a fan of the topics that were at my disposal. I think they don't get to an Algebra 2 level fast enough, especially since I only require that to be the 60. So I made another quiz. I'm going to share that link for the new quiz out on Google Classroom here after we conclude. And that quiz assignment will be due on Monday at 3:30. Should be pretty easy to get it done before then. It's only 7 questions long, I think. Please take your time because, again, you do have to get at least a 70%, which is a 5 out of 7 on this quiz in order for it to be considered complete. And you will be able to do it as many times as you want to. But if you don't have any questions, that's it for the video lesson. And you would need to redirect your attention to Google Classroom to start on the assignment. But otherwise, if you don't have any questions, you don't need to stick around any longer. The lesson is complete, and I'll upload the video lesson to the same Google Classroom post where I post the assignment as soon as I possibly can. Okay, so we're done for the day lesson-wise. I will post that stuff to Google Classroom. Absolutely, I can check on that as well, but I'll have to get all this other stuff organized first, so watch your email. Okay, I'm happy to check on that for you. It'll send you an email. All right, that is it for today, folks. So if you don't